Hi, and welcome to this look at a multi-topic rates and orders exam question. So when I say multi-topic, what I mean is there's lots of different aspects of the rates and orders part of the course that are included in this same question. So having a quick glance at the whole thing, you can see that there's a rate concentration graph, and that has iodine in it, concentration of iodine. And you'll also notice that the concentration of iodine is not included in the initial rates data. So you have to use the graph to work out the order with respect to iodine. The order with respect to propanone and HCl can be determined from the initial rates experiments. And one thing to always remember is if you're asked to work out the rate equation, you'll be asked to work out the rate constant as well. Don't forget to include the units, even if they don't actually specifically ask for them. So let's start with working out the order of a reaction from a concentration rate. So you can see that the relationship between the change in concentration of iodine and the rate is such that iodine actually has no effect on the rate because it's just a straight horizontal line. So that means it must be zero order with respect to iodine. If we move on to the initial rates data to work out the orders, don't forget you need to include your reasoning as well. So you'd always start by finding two experiments where the rate changes but only due to one concentration being altered. So I'm going to start with experiment 1 and 2, where you can clearly see that HCl doesn't change, but you double the propanone concentration and you end up doubling the rate. So it must be first order with respect to propanone. If we move on to experiment 2 and 3, this time round the propanone stays the same, but the concentration of HCl increases by 2.5, and so does the rate. So therefore it must also be first order with respect to HCl. So now we know the orders, we can use them to work out the rate equation and the units and the value of K. So let's have a look. Obviously, you're going to do the format rate equals K times concentration. So you put in the concentration of propanone and the concentration of HCl, and you don't raise them to the power of anything apart from 1. So we don't put the 1 in there, you just leave it out. So rearranging this so that K is the subject and taking one of the sets of values, you could use the data from 2 or 3 if you wanted to. Inserting that in gives you 7 times 10 to the minus 5. So to work out the units, all you do is you put in the units of rate at the top, obviously, and the 2 units for concentration at the bottom, multiplied together gives you mole to the power of 2, decimeter to the power of minus 6. And doing a bit of cancelling, it gives you mole to the minus 1, decimeter to the power of 3, seconds to the minus 1. And then the final part of the question moves on to a different reaction where they need you to work out the rate mechanism. So the first clue is it says the first step should be the rate determining step. So the first step is a slow step and the second step is the fast step in this mechanism. So the ratio of the orders is always the same as the ratio of the moles in the rate determining step or the slow step. So it must mean there's 1 mole of hydrogen and 1 mole of iodine monochloride. Now we don't know what they're going to turn into yet, so we can go back to the overall equation to help us here. And you can see there's a second ICl not on the slow step, so this must come up in the fast step, so you end up with 2 moles combined together. So that must mean that what's going to happen is that these two will combine together to make this here. Now, at this point, we need to do a bit of playing around and a bit of problem solving. So think about what H2 and ICl could turn into. Now, in the overall equation, you can see that you need to make some HCl. So one of those can be formed because you only have 1 Cl in the slow step, but you have 2 H's. So one of those H's and that Cl can make an HCl. And think about what you'd have left behind. You'd have a hydrogen iodide. Now the hydrogen iodide should be used up because it doesn't appear anywhere in the overall equation. So what you do is you put the Hi reacting with the ICl in step 2. and look at what you've got left behind. It all falls into place, giving you 2 HCl's and I2. Now, obviously there's other ways in which this could work. This is just one possibility, maybe it's the most obvious one, but there are other ways in which this mechanism could work, provided you end up with the overall equation at the top and you end up using the same mole ratio of H2 to ICl in your first step. You can work that round any way you want, provided those two things end up in place. Okay, hopefully this has been a useful look at this question. Until next time, thanks for listening and see you soon.